So we're at our last lesson for Unit 7. It's section 7.7, Pascal's Triangle and Binomial Expansion. Let's review first how to expand x plus y squared, right? So we did that in grade 10, I think. We just write it out twice, x plus y times x plus y, and then we distribute. Some of you learned FOIL, which is first, outside, inside, last. Others just are making sure you do every combination. So I've got to multiply my front term, which is an x, by the front term here. So I get x times x is x squared. Then I multiply my x by the y. That gives me alphabetical order, xy, not yx. Then these two inside terms, y times x, again alphabetical order, is xy. And then my last one in each bracket is y times y. That gives me y squared. And we almost always have some like terms that we collect when we're done. So we get x squared plus 2xy plus y squared. So now try something new. What if we have x plus y to the power of 4? Okay, power of 4, that's a lot. That means writing this out 4 times and then expanding each term. So for example, this x needs to be distributed to this x and this y, whoops. Also to this x here and this y over here, and to this x here and to this y here. Then we need to do the same thing with this y, and then all the x's and all the y's, they all get distributed into each other. So I'm going to show you a shortcut for this. We're going to need Blaise Pascal's help with this. Monsieur Pascal was born in France in 1623, and he saw some patterns that we can use to expand binomials. Binomials, of course, this only works with binomials. What we're learning today, binomial is a bracket with, say, 7 plus 2. That's a binomial, right? 2 terms, a plus b. That's a binomial.
So you can check my arithmetic here. I did a couple of expansions, a plus b to the 4th power. So if you take a plus b times a plus b times a plus b times a plus b 4 times, collect your like terms, you're going to get this value, 1a to the 4th plus 4a cubed b to the 1st, 6a squared b squared, 4a to the 1st b cubed, plus b to the 4th. And I've also done the same thing for a plus b to the 6th power. So I've got the coefficients highlighted in red here. So just to kind of illustrate this Pascal's triangle. So here's going to be a good old Pascal's triangle. So the way that you start Pascal's triangle is you just make a number 1. And then what we do from that is we make 1s to the left of the first one and a 1 to the bottom right of the first one. And we do this again. But now what we're going to do is we add 1 and 1, and we get the number 2 in the middle, and then we just stick another 1 off to the side. And then we just keep this process up. So I'm going to put another 1 over here. If I add 1 and 2, I'm going to get 3. If I add 2 and 1, I'm going to get another 3. And then I'm going to drop down another 1. Okay, so let me do this again. So if we add 1 and 3, we're going to get 4. If we add 3 and 3, we're going to get 6. If we add 3 and 1, we're going to get 4 again. And then we're going to get another, we just stick another 1 at the end. So let me erase my little arrows here, just so they don't, so hopefully you see what's going on now. I'm going to stop drawing the arrows, and hey, look at those numbers, 1, 4, 6, 4, 1. Look at the coefficients, 1, 4, 6, 4, 1. It's going to turn out that every row is going to give you the binomial coefficients. So let's do 2 more. So we would have to the 5th power, 1 and 4 would give us 5, 4 and 6 would give us a 10, 6 and 4 would give us another 10, 4 and 1 would be 5, and then we drop down our 1. Let's do maybe 1 more. So we'll stick a 1 off to the side. If we add 1 and 5, we get 6. If we add 5 and 10, we get 15. If we add 10 and 10, we get 20. If we add 10 and 5, we get 15. If we add 5 and 1, we get 6. and then we stick another 1 down there. And hey, look again at the coefficients. On my a plus b to the 6th power, we had 1, 6, 15, 20, 15, 6, and 1. And those are exactly the numbers in this row of Pascal's triangle. So the idea is the first row is going to correspond to the exponent of 0. So imagine if you had a plus b to the 0 power. Well, you would just get 1 would be the coefficient. The second row is going to correspond to the exponent of n equals 1. And again, that makes sense. You know, if you had a plus b to the 1st power, I mean, what are you going to get? You're going to get 1a plus 1b. So that certainly is an agreement. And then you can just keep counting down. The third row is going to go with the exponent of 2, and then so on and so forth. So that's going to be our exponent of 3, our exponent of 4. This is going to be our exponent of 5. And the numbers at the bottom would go with the exponent of 6. Okay, so again, so just kind of a neat little trick, I think, to get the binomial coefficients. You can just make this little Pascal's triangle, fill it in, find the appropriate row that you need.
Okay, so that ended kind of abruptly, but he was going to go on and on, so I just cut it off. On your piece of paper, so you're taking your own notes today, there's no handout, I want you to press pause here and I want you to create your own Pascal's triangle up to n equals 7. That's the 7th power, which is going to be the 8th row. So just press pause here and draw that triangle, and then I'll show you the correct one in a second. So here is the triangle. This is going up to 10, n equals 10. So we have more than what we need on this diagram for our question. Our original example, remember, that we're working on is just x plus y to the power of 4. What row do we need for that one? We need this row here. The one with the 4s in it is the one that we need. So let's go back to our first example. Remember, we had this, and I had expanded it all out, but we're not going to expand that way anymore. Not with a power of 4. That's only efficient if you have power 2 or 3. You can do that pretty quickly, but power 4 or higher, we're going to use our new strategy. So we're not going to do this. Instead, here are our binomial expansion steps. The first step is to write out the coordinates from your triangle that you drew, but we need to leave space for variables because we need x's and y's in here somewhere. So let's get these coordinates kind of spread out here. Okay, now we need the variables, but to figure out this, we're going to watch another video. So this video that I'm going to show you, it's kind of a, I picture him as an older retired teacher who just decided to start making some videos. He sounds like he's having a great time because you can hear him chuckling along and everything. So it's kind of an amusing little video. I mean, he just seems to be having fun with it. So the next thing we're going to do is watch the video.
All right, let's talk about what? Binomial expansion, x plus h. Oh, let's make it tough. Let's raise this guy to the 4th power. Wow, this is going to be a killer. Nah, no, it won't. All right, so the first thing I do, start with the guy on the left. That's x. And this guy here, that's 4. So I just write that down, x to the 4th. That was easy. Now I come over here and I write it again, but this time I take 1 away from that, x to the 3rd. And it's positive, so I'll put a little positive sign there. Then I come over here and I'll write it again, x to the, let's take away 1, x to the 2. And I'll come over, oh, it's positive, I'll put a positive in there. Then I'll come over here, do it again, x to the 1. I come over here, do it again. That's, oh, I forgot to put the positive in there. And that always gets me. And over here, x to the 0. Well, anything to the 0 power is the 1. But we'll do it anyway. Now we start with the guy on the right, the h. And of course, we'll start with the 4. And we'll go to the right. We got h to the 4th. Oh, I forgot to put the positive sign in there again. goodness. All right, and then we'll take one away from that. We got h to the third. And then we come over here, and we got h to the second. And we come over here, we got h to the first. And we come over here and do it again, h to the 0, which is 1. So we know that anything times h to the 0 is 1. 1 times x to the fourth is going to give me a what? X to the fourth. And, oops, that didn't look good, did it? Yeah. And what about this guy over here? This guy that's 1 times h to the fourth. X to the 0 is 1, so anything times 1 is itself. So this guy is h to the fourth. And a positive sign. I always forget that. That's why I always do so well on tests. Oh, no. Anyway, so let me copy this stuff down here. And there we go. Well, that's good so far. Let's move that down a little bit, get some fighting room. And that's almost our entire answer. Almost. We got to put coefficients in front of them boys. How do we do that? Well, it's a real easy way to do that. First, got to move these over a little bit. I put the plus sign way too close, because I got to put the coefficients in there. Oh, that's going to be trouble. Move that over there. Try and move that over here. Ah, that's not bad. Not bad. So far, so goody. Now, where do I get the coefficients for these guys? Coefficients being the guys you put in front of these variables. Where am I going to get those guys from? Aha, I know. He goes to a blank screen. We'll do the Pascal. We'll get him from Pascal's Triangle. We'll cheat. How do you do Pascal's Triangle? Well, repeat after me. 1, 1, 1. 1, 1, 1. 1, 1, 1. Now, next one. 1, 2, 1. 1, 2, 1. So that was 1, 1, 1, and then 1, 2, 1. That was easy so far. The next one will be 1, 3, 3, 1. 1, 3, 3, 1. What's the next one? 1, 4, 4, 1. With a 6 in the middle. What's the last one I'm going to do? 1, 5, 5, 1. With a 10 and a 10 in the middle. I did that bad. I get that over here. Right there. That looks good now. Oh, the 5 looks terrible. Oh, I'm fired. Move this over. Ta-da! We be good. This guy over here is the 0th row. That's for anything you raise to the power of 0. This is for anything you raise to the power of 1. This is for anything you raise to the power of 2. This is for anything you raise to the power of 3. And this is anything you raise for anything you raise to the power of 4. That's our boy. 1, 4, 6, 4, 1. Otherwise known as 1, 4, 4, 1 with a 6 in the middle. Here's our guy. Now we scooch on back to the other screen. There's our answer, right? Let's put the 1, 4, 4, 1, 4, 4, 1 with a 6 in the middle guys in there. 1, 4, 4, 1 with a 6 in the middle. That's our answer. Well, we got a 1 in there. Whenever there's a 1, you don't have to write the 1 down. You know, if it's a coefficient, you don't got to do it. So, you know, you don't got to do it. Don't do it. And here's a 1 here. The h power, that's a 1. And see this x over here? That's got a 1 there. You don't have to put that down. Any more 1s are hanging out around? No, there isn't. That's it. That's it. We have done it. We are so clever. I screwed that up. Let's circle our answer. Oh, that's it. That's our answer. X plus h to the fourth. This is our answer. We are so clever. Or as they say in Korea, 천재입니다. You're geniuses. 천재입니다. Bye-bye now.
So that's kind of a funny guy. I like the way he just really seems to love his job there. So back to our example. We now are, there is a typo, sorry, in step one. Step one here says coordinates. That should say coefficients. Coefficients, write the coefficients from the appropriate row of Pascal's triangle. So these are the coefficients, not the coordinates, sorry. So now we're going to insert the variables. We're going to follow the ascending descending power from the pattern from the video. So let's see if we've figured this out here. So in front of the 1, my first coefficient, I'm going to have x to the power of 4. And then it's going down, x to the power of 3, x to the power of 2, x to the power of 1, x to the power of 0. Okay, that's the ascending part. Now we do the descending pattern. So the descending means we're now going to look at the y's. So y to the power of 4 should be the last one. So if I start here, sometimes it's easier. I'm going to start at this end. So this is my y to the power of 4, y to the power of 3. So we're descending from the opposite, which is really sort of ascending, I guess. Y to the power of 2, y to the power of 1, y to the power of 0. So yes, we ascended. We're actually, from left to right, we are ascending right now. This can be cleaned up right here. As he told you in the last video, if you have a coefficient of 1, you don't need to write it. So I'm not going to write the 1, but the x to the power of 4 goes there. And of course, y to the power of 0 is equal to 1, so I don't need to write that. So I have x to the power of 4. These should all be plus signs in here. So the next part we write is plus 4x cubed, and the y power of 1, I just write a y. I don't need the power of 1. Then we have 6x squared y squared, and 4x to the power of 1, which is just x y cubed, plus, again, we don't need to write a coefficient of 1, and x to the power of 0 is just 1, so that's going to be y to the power of 4. So that is expanding this power of 4 without having to write it all out like this and then distribute everything and everything, right? That's a lot of work. So this is much faster. You wouldn't use this again if you had power of 2, like if it was just squared or power of 3, it's pretty quick to distribute that yourself. But anything more than that, you're going to make too many mistakes, so it's better to try something else. So let's try a harder one. Expand and simplify. The first thing here is I have a negative sign in the middle, not a positive sign. And for these little formulas to work, it needs to be a positive sign. So I just have to rewrite it with an extra set of brackets so that this term gets the negative. The 3 gets the negative. It doesn't just be left off in the middle. So if we think of the way we did the previous questions, x was the first term. So in this case, that's the 2a cubed. Y was the second term, and that in this case, that's the negative 3b squared. The first thing we do is write out the coordinates from the appropriate row of Pascal coordinates, coefficients. That's because I copy and pasted this comment onto this slide. Coefficients from the appropriate row. So go back to your triangle, take a look, figure out which row you need. Right, we've got a power of 5 here, so figure out the row that we need and then put your coefficients in, leave spaces for your variables. Something like that. Next, we're going to insert the variables in the correct order, and I just put this in here to help you remember that this is like your first term, your 2a cubed is like your x, and then y is your second term, which is negative 3b squared. So I didn't leave enough space here, so I'm going to rewrite my coefficients. I'm going to move it way over here. Equals, my first one's a 1. So I start with my first term to the highest power that I have. So that's going to be 2a cubed to the power of 5. And I'm going to leave a bunch of space because I have to put more in there. I go to the 5. And that is, I'm still working just with the first term, 2a cubed. This time the power is 4. So I'm descending here. I should write smaller. I think I'm going to have to write smaller. 10, 2a cubed to the power of 5, power of 3. Another 10, 2a cubed. This time we're at a power of 2. Okay, I'm going to have to go below here. So I'm taking this 5 and I'm moving it down here. This 5 is this 5. 2a cubed. Now we're to a power of 1. And finally we've got a coefficient of 1, and that's 2a cubed to the power of 0. All right, so that is the first part here. That's using this x equals 2a cubed right there. That was our first part. Second part. Now we're going to do the 3b cubed, which is what we had in our previous example as a y. So 3b squared. I'm going to start at the very end, and it's going to have a power of 5 when it's at the very far right. So over here I have, remember it's negative 3b squared to the power of 5. And then we keep going this way. So hopefully you're doing this along with me on your paper. You can pause and do it at your own speed and then catch back up with me if you want. And the last one, negative 3b squared to the power of 0. Okay, so that's done. Now we have to simplify. And step 3 is to simplify. There's a lot of simplifying to do here on this one. There's a lot we can do to clean this up. So I think I can fit it all here. Maybe if I start over here. This one, I don't need to worry about that. This is a power of 0. That's all going to turn into a 1. So what I have here is a power of 5 that needs to be applied to a 2. So it's 2 to the power of 5. That gives me a 32. And a cubed to the power of 5 is going to give me a to the power of 15. Because we multiply exponents. That's a power of a power law. So we multiply exponents. Next set of numbers starts with a 5, so it's not going to clean up as easily as this one did here. So I'm going to put the 5 back out there. Let's just do one piece at a time. 2a cubed to the power of 4. So this power has to go on to the coefficient 2 and the a cubed because it's touching the bracket. Everything in this bracket gets the power of 4. So 2 to the power of 4 is not 2 times 4, right? It's 2 times 2 times 2 times 2. That's going to give me a 16. And a cubed to the power of 4, we multiply these two together, 12. Next piece. Oh, sorry, I missed that. Negative 3b's got to go in there. Jumping the gun here. Negative 3b squared, that's just a power of 1, so I don't need to do any work with that. Now we're on to the 10. So this is a power of 3. 2 to the power of 3 is 8. And a cubed to the power of 3 is a to the power of, we multiply, 9. Times, this is squared out here, negative 3 squared is 9. And b squared squared is b to the power of 4. Next piece is here. Get the 10 again. This power of 2 comes into the 2 to the power of 2 is 4. A cubed and then squared is going to be a to the power of 6 times negative 3 cubed. Negative 3 times negative 3 times negative 3 is negative 27. B squared cubed is b to the power of 6. Now we're on to this piece here. I'll just angle this down a little bit. 5. So 2a cubed to the power of 1 is still 2a cubed. Negative 3b squared to the power of 4. So negative 3 to the power of 4 is 81. B squared to the power of 4 is b to the power of 4 times 2, 8. And then my last piece will clean up nicely. This power of 0 means this all is going to turn into a 1. And then I have a 1 here. So all I really have is this power of 5. So the power of 5 comes into negative 3. And that's going to be negative 243. B to the power of 10. So it's still not done. We're still on step 3 here. Simplify. We're still on this step because we haven't finished yet. So 32, the first one, this is one term. So I can just write that 32 a to the power of 15. That one's done. Now we need to put these pieces together here. So I want you to press pause, try to collect all of each term, right? This term needs to be collected, all of these need to be collected. Press pause, and this one's already done, and then come back and let's see if you got the right answer. All right, so you've got the rest of your answer in here, and I'm just gonna pull it up. Oh, I didn't put it in there, sorry. I have it here, just a second. I have to skip through. Here it is on this one right here. This is your answer right here. There's your answer. That's what you should have. So check and see if you got the same thing. And speaking of check, we want to make sure after all this work that it is right. So we're going to sub in with some really easy numbers here. We're going to sub in with ones. I'm going to sub in with a equals 1 and with b equals 1. So you sub into the original question and then our solution. So here's our original question down here. I'm going to put a 1 in for a and a 1 in for b. And then simplify that. 2 minus 3 is negative 1. The power of 5 is just negative 1. Now I want to check my answer, all the stuff that I wrote out here. Right? I want to see if this is right here. So I sub in a 1 everywhere. Looks like that. Tidy it up a bit, and then I'm getting out my calculator, and I get negative 1. So we know our answer is correct. Your homework is in your textbook on page 466. You only have a few questions to do. That's because they can take a long time. This is a power of 5 that we did here, and that takes a pretty long time. I think the highest you'll get is maybe a power of 6. I would never test you or quiz you on anything longer than that. It would just take it would take way too long. So, but of course you want to practice with those and check to see if you get stuck, if there are answers already on D2L, but let me know if you have any questions. That's it.